Hello and welcome to Weekly Dev Tips. I'm your host, Steve Smith, aka Ardalis. This is episode 26, where we'll look at how we can layer multiple patterns together to get great results. Don't forget you can follow Weekly Dev Tips on Twitter as well as in your favorite podcast app. The show is now available on Spotify as well, so welcome back, Spotify listeners. And if you're finding these tips to be helpful, please take a moment to leave a review wherever you're listening from. I read and appreciate every review. This episode is sponsored by devIQ. devIQ offers online training for software developers and designers covering topics like user experience, .NET development, and my own course on ASP.NET Core. Check them out at deviq.com. This week, we're sticking to the Patterns and Repositories theme. I started down the design patterns path with episode 17, so you should start from at least there if you want to listen to the sequence more or less in order. In this episode, we'll look at some combinations with other patterns that make using the repository pattern even more attractive. I apologize for the slight break in episodes. I was trying to get together a decent sample for what we're going to talk about today, and I just finished that up recently. So there is a GitHub repository as well as a blog post that you can refer to from the show notes. Okay, so in the last episode, I mentioned how the repository pattern works very well with the strategy pattern so that you can use dependency injection with it. This is the first of many ways in which you can combine repository with other patterns and is probably the most powerful of them all, though probably taken for granted by many. I described the strategy pattern in episode 19. Let's look at two other patterns now that we can combine with repository. First, let's talk about a common pain point with repositories, custom queries. I talked about the need to encapsulate query logic so it doesn't leak out of your repository in episode 18. However, I saved a powerful technique for doing so until this tip. Sorry, there's only so much I can put into each one of these and keep them short. If you follow my earlier advice and you don't leak query logic outside of your repositories, it's likely your repository implementations have a bunch of custom query methods. Maybe you have standard getById and list methods, but then you might also have things like list by state, list by model, list by owner, etc. Maybe you have methods that correlate directly to business use cases or even UI concerns, like list premium customers or list for search screen. The point is, you may find yourself with the code smell of too many one-off custom query methods on your repositories. This also makes it so you can't just use a generic repository because these custom queries generally only apply to a particular type of entity. This is all pretty common, and the worse it gets, the more cumbersome it becomes to work with repositories. The solution to this problem is to introduce another pattern. The specification pattern is designed to encapsulate a query within an object. I mentioned it briefly in episode 24. It's especially useful when you're using an ORM tool like Entity Framework or EF Core, because not only can you encapsulate filter expressions, you can also specify which properties to eager load. Thus, you can create a specification for a shopping basket type that might be called basket with items by customer ID or something similar. A typical specification I use will include the filter expression to be used with the where link expression and will let me specify which properties and subproperties I want the query to return with the result set. What are the benefits of using this pattern? First, you eliminate duplication of query logic if you were previously letting client code create queries on the fly. I already recommended that you not do that. Second, you establish a library of known queries that your development team can review, reuse, and discuss. These should be organized so they're extremely discoverable, so there's minimal need to try and reinvent the wheel when someone needs a particular query that already exists. They also help clean up your repositories, eliminating most of the scenarios where you would need non-generic repository methods, and thus dramatically reducing how many repository implementations you need to write and maintain. Your repository code will better follow the single responsibility principle and the open-close principle, and you won't need a bunch of custom iWhatever repository interfaces. Finally, you can easily unit test your specification's filter logic to ensure it's correct and provide examples for the team. I should also mention that each one of these specifications has a name, and just having a name makes it especially useful because you can refer to that name in your conversations with other developers or even with the customer. I mentioned there were two patterns we were going to try and cover this week. The second useful pattern you can use with repository is the proxy or decorator pattern to add caching. I call this combination the cached repository pattern, and I've written a number of articles about it. I mention both patterns because they're functionally the same, proxy and decorator, but differ based on intent. A proxy controls access to something. A decorator adds behavior to something. A cached repository controls access to the real underlying repository, exposing it only when the result isn't in the cache. In this way, it's a proxy. But it also is responsible for adding caching behavior to any repository. In this way, it's a decorator. Either way, it's an extremely useful pattern. Most applications make a lot of queries to their database for results that don't change frequently. A lot of applications use a database to define some or all of their navigation or the contents of common drop-down lists on forms. These and other common results are great candidates for caching, but often this behavior isn't added because of the work and complexity involved. Adding caching to a method in a data access repository isn't ideal, since it couples two unrelated concerns and breaks the single responsibility principle. It's also not very reusable. A better approach is to create a generic cached repository of T that can be used for any type that would benefit from caching. Determining whether or not to use this caching functionality can be controlled centrally for the application wherever its services are configured. Circling back around to the specification pattern, you can combine it with the cached repository to help with key generation. Every cache entry needs to have a unique key, and you need to take care when constructing keys that you take into account any variables or parameters that were used for a particular query. Your specification objects know exactly which parameters they require and can easily expose a cache key property that can be used by your cached repository. You can also add a property to toggle whether certain specifications should be cached at all, if you find that helpful. If you'd like to see what this looks like in a simple sample application, check out the eShop on Web sample on GitHub. I have a link to it in the show notes. There's also a free 110-page ebook that goes along with this sample that I encourage you to check out. I developed both the book and the sample for Microsoft as a free resource, and they're both up to date with .NET Core 2.1 and will continue to be updated. You can also look for the blog post and GitHub sample that goes with it on using the cached repository pattern in ASP.NET Core. That's it for this week. Thanks for listening, and I'll see you next time on weeklydevtips.com.